In section 10.7, operations in scientific notation, we're going to learn how to add, subtract, multiply, and divide numbers that are written in scientific notation. Now, the first thing I want to go over is this, though. You can still add, subtract, multiply, and divide by taking numbers, putting them back into standard form, and then once you get your answer, putting it back into scientific notation if that's how they want you to answer it. So I want you to just write down the problem. We're just going to do a problem together before I go over any rules. 2.4 times 10 to the third plus 7.1 times 10 to the third. Now in this problem, you can kind of see that I'm adding two numbers that are written in scientific notation. But let's say I just said use the order of operations to solve this. What would you do first with order of operations? You'd start with exponents. So then, that would give you 2.4 times 1,000 plus 7.1 times 1,000. The next step in order of operations would be what? Multiplication left to right. So 2.4 times 1,000 would be 2,400 plus 7,100. If we add these two numbers together, that gives us 9,500. If I wrote it back into scientific notation, that would give me 9.5 times 10 to the third power. So can you see what you can do with this to go directly to this? Hopefully you can realize that all I have to do is add 2.4 and 7.1. So the first thing we're going to do is go over our rule for adding and subtracting. Here's the easy part. To add or subtract numbers written in scientific notation with the same power of 10, all you do is add or subtract the factors. That's the easy part. If the numbers have different powers of 10, rewrite the numbers so they have the same power of 10. Example 1. Find the sum or difference written in scientific notation. So let's do A. Let's do an example. In parentheses, 4 6/10 times 10 to the third power plus 8.72 times 10 to the third power. If you are adding or subtracting, if the powers of 10 have the same exponent, 10 to the third and 10 to the third, all you have to do is add or subtract the factors. So 4.6 plus 8.72. That gives me 13.32 times, and then the 10 to the third power stays the same. Are you done? No. And the reason is that you are not done is because this number right here is bigger than 10. Remember, this number has to be between 1 and 10 or 1. Because it's bigger than 10, we have to rewrite it as 1.332. Now, this number is going to be written as 1.332 times 10 to the first. All of this. 1.332 times 10 to the first. And that's in scientific notation. The times 10 to the third comes down. And now we can use the product of a power property. Same base, we have a 10 and a 10. If you have the same base, what do you do with the powers? You add them. So our final answer would be 1.332 times 10 to the fourth power. Example B. We are now subtracting two numbers written in scientific notation. Now let me tell you, if you find this confusing, that's okay. If you want to put these as regular numbers, subtract them, and then put them back into scientific notation, you are more than welcome to do so. The first thing we have to do is we have to rewrite one of these numbers so that the powers on both are the same. It's completely up to you which one you want to use. I'm just going to leave 3.5 times 10 to the negative 2 alone. And I'm going to rewrite this as times 10 to the negative 2. So, if I separate 10 to the negative 3 into 6.6 times 10 to the negative 1, notice what I just did. 10 to the negative 1 and 10 to the negative 2 added together, the powers added together gives me 10 to the negative 3. I took one of them away because I want to make these the same. So now we have to simplify this. So 3.5 times 10 to the negative 2 comes down. Since this is negative 1, I go 1 to the left. So that gives me 0.66 times 10 to the negative 2. All I do now is I subtract my factors. 3 and 5/10 minus 6,600. So 3.5 minus 0.66. That gives me 2.84. And my power of 10 stays the same. This number here is already between 1 and 10. Therefore, that's my answer. Example C. Now, some of you may be thinking, I don't get this. That's okay. We'll go over this. We'll do another example. If you understand it, pause the video, skip ahead, and see if you got it right. Notice first that our factors of 10 are not the same. So we have to make them the same. So that gives me, I'm just going to leave the first one the same. And this one, I need to make it times 10 squared. So what would this give me? 3.41 times 10. Now, what is my missing factor here? I'm going to box it in red. What should that give me? Now, if you're remembering, we just want to fill in the blank. What number plus 2 gives me negative 1? This is going to be negative 3. Here's how I got that. If I multiply the same base, negative 3 and 2 combined together give me my original negative 1. It's just another way to rewrite 10 to the negative first power. I then am going to simplify that. I'm going to take my decimal, move 3 to the left. And that gives me 0.00341 times 10 squared. My first one comes down. And now you just add the factors together. 8.20341 would be the sum of the factors, and then times 10 squared comes down. Is my final answer between 1 and 10? The answer is yes. Now, if you wanted to, you could have just changed this to a normal number, changed this to a standard number in standard form, added the two numbers together in standard form, and rewritten it in scientific notation. Now, multiplication and division is easier. In multiplication and division, you're going to multiply or divide the factors and the powers of 10 separately. It's going to be really easy. So, let's do an example. Example 2. Multiply these two numbers in scientific notation together. 3 times 10 to the negative 5th times 5 times 10 to the negative 2. Now we're going to use properties that you learned back in elementary school. You do not need to show all these steps. But I'm going to show you what happens. You're just going to multiply or divide the factors and the powers of 10 separately. So my factors are 3 and 5. My powers of 10 are 10 to the negative 5 times 10 to the negative 2. Now you don't need to write it like this, but I'm showing you why it works. What property did I just use to switch the order that I'm multiplying in? It's commutative property. Commutative property in multiplication told me that I can rewrite these in any order I want. And then we're going to use the associative property to group these together. So I can multiply 3 times 5, which gives me 15. Times. Now, 10 times 10 to the negative 5th times 10 to the negative 2, we add the powers. That gives me 10 to the negative 7. But now I do not have a number between 1 and 10. So I'm going to rewrite 15 as 1.5 times 10. What should the power be? To the first power. The 10 to the negative 7 comes down. I then add the powers again, since they have the same base. And my answer would be 1.5 times 10 to the negative 6th power. In part B, we're going to divide. 1.5 times 10 to the negative 8th divided by 6 times 10 to the 7th. So the first thing you can do, just divide your factors. Take 1.5 divided by 6. That gives me 0.25. Times. I now have to divide 10 to the negative 8 divided by 10 to the 7th. So we subtract the powers. Now, don't make a mistake here. This is a very easy mistake for students to make. You are not going to just combine them together. You're subtracting. So that's going to give you the power negative 8 minus 7, which would give me 10 to the negative 15th. Now, is this number written in scientific notation? No. Why not? Because this number is not written between 1 and 10. So I'm going to go one step further, and I'm going to rewrite that as 2.5 times 10 to the negative 1. The 10 to the negative 15th comes down, and my final answer gives me 2.5 times 10 to the negative 16th power. In example 3, we're going to start using our real-life applications. Here we have a picture of the sun and the earth. We want to know how many times greater is the diameter of the sun than the diameter of the earth. As you can see, the diameter of the sun is 1,400,000. The diameter of the earth is 1.28 times 10 to the 4th kilometers. So looking at it, it's pretty easy when I ask you, how many times greater is 10 than 2. All you do is divide. 10 divided by 2, you get 5. If you wanted to write these both as normal numbers, you could divide them. The problem is sometimes you may have numbers that are too big for your calculator. So let's write them both in scientific notation. Well, the diameter of the earth is 1.28 times 10 to the 4th. Well, that's going to be smaller, so that's going to be on bottom. What would the diameter of the sun be written in scientific notation? If you took this and wrote it in scientific notation, 1,400,000, what would you get? Hopefully you have 1.4 times 10 to the 6th power. Now, what do I do next? What should I do? Sometimes I feel like I'm Dora the Explorer when I'm waiting for you to answer questions. So you should take 1.4 divided by 1.28. That would give me 1.09375 times. Now what would I do with the powers of 10? What would 10 to the 6th divided by 10 to the 4th give me? It'd be 10 squared. Now, if I'm asking you how many times something is greater, you're going to tell me an actual number. You're not going to say, well, it's approximately 1.572, times whatever. You're going to actually give me a number. So you're not going to say 1.09 times 10 squared. You're going to write this as a normal number. So times this by 10 squared, decimal goes over twice, you get 109.375. So I want approximately. Approximately how many times bigger is the diameter of the sun than the diameter of the earth? You would say approximately or about 109 times greater.